So let's look at the math around compound interest and how that affects what we call future value and present value. So compound interest in general is what we see in finance economics. Simple interest is used less frequently. You might see it in some capacity, but compound interest is a big one. So it's used for money borrowed, invested for a long period of time, savings accounts, mortgages, GICs, loans, RRSPs, all that kind of stuff uses the idea of compound interest. So let's look at some examples and utilize the formula related to it. So here's our compound interest or future value formula. So we have FV, so that's our future value, accumulated value, maturity value. So in simple interest, we use that as S. So that was basically our future value. So what we see in the future, our principal plus our interest. PV is our present value or the original principal value. So we saw that in simple interest as P. And then we have a similar type formula. So 1 plus I, where I is what we call our periodic interest rate. And it actually has an embedded formula in it, which is R, which we already saw as our rate of interest, over M, which is our compounding periods, which we'll talk about that in a second. And then we have that bracket to the exponent N, where N is the total number of conversion periods. And it's M times T. So T, we've already seen that as our time period in years. And M is a new one that we haven't really seen. So that's actually the number of compounding periods per year. So let's take a moment to talk about what is M actually representing. So it's compounding periods. So it's the time interval between the occasions at which the interest is added to the account or added to the principal. It's also called the compounding period. So there's a couple different ones. So if your interest is compounded annually, you see it once per year. If it's compounded semi-annually, twice per year. If it's compounded quarterly, 4 times per year. Monthly is 12 times per year, etc., etc., etc. If you sort of want a rule of thumb, semi actually means twice per. So if you see something that says semi-annually, that means twice a year. If you see something that says bi, then usually that means every 2. So for example, let's talk about these ones at the bottom. So semi-monthly would mean twice per month. So every month is 12, but we're doing it twice per month. So that would be basically 2 times 12 gives me 24 for my compounding periods per year. But bi, on the other hand, means every 2. So bi-monthly would mean that monthly is 12, but I'm only doing it every 2 months. So we'd actually get 6 there, divide by 2. And bi-weekly, same thing. Weekly is 52 weeks in a year, but we only want to do it every 2 weeks. So that's 52 divided by 2 gives me 26 compounding periods per year. So this is actually really important to determine how we actually come up with our present value and our future value numbers. So let's just do an example of calculating our new I formula and our N formula. So I, remember, is going to be R divided by M. So it's your periodic interest rate. So it's your rate of interest divided by your compounding periods. So it's going to be R divided by M. And then your N value is your total number of conversion periods. So it's your time period, so how long your loan is, or your whatever you're looking at, times your number of compounding periods. So M times T. So we're pretty comfortable with R and T from simple interest. So we have 11.5 per year compounded semi-annually for 8 years. So we have 3 bits of information in here. So this is our R value. And remember, we need to put that in decimal format. Semi-annually would be my M value, and either I can go to the chart or think about what that means in terms of semi is twice per, so 2 per year. And then for 8 years would be my time frame. So remember, this needs to be also relative to the number of years that you have. So our R value is 0.115 as a decimal. M is semi-annually, so it's 2. Recommendation is to leave this in fractional form so that you don't lose any of the integrity until the very end. So I'm just going to leave it as a fraction. So that would be my I value. And then my M value is, again, semi-annually would be 2. And I'm going to have an 8-year situation. So it's already in year format, so I can just plug that into my formula. And we can do that computation because it'll give us an exact number of 16. So we are going to need to do some mini computations, probably best to do them off to the side and bring them into your formula when you're actually calculating future value or present value.